Hello friends, this video on relation and function part 22 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 21. We have to show that the function r star to r star defined by fx equal to 1 by x is one and onto, where r star is set of all non-zero real numbers. Please note this is crucial here because r star to r star is our domain and codomain. This is a domain and this is codomain. And the question says again, is the result true if the domain is replaced by n, that is from n to r star, where codomain is still r star. So we have to first say where the function fx equal to 1 by x is 101 and onto for r star to r star, and then we have to find where the function is still 101 and onto for n to r star. So this is one example where I have told that these things matter. The domain and codomain matters a lot. So now let's draw this pattern here. This is from r star to r star. So if you see, r star is nothing but set of all non-zero real numbers. So it can be any real number that is non-zero. I can take 1 by 2, I can take 1, I can take minus 1 by 2, I can take 3, minus 1 by 3, any number I can take. So if you see, for this 1 by 2, if you take 1 by 1 by 2, that becomes 2. 1 by 1 is 1. Minus 1 by 2 will become minus 2. Minus 3 will become minus 1 by 3. And minus 1 by 3 will become 3. So if you see, if you take any number in this domain, you will have a unique value in the codomain also. Correct? Since it is all non-zero real numbers, 0 is not there. If it's 0, 1 by 0 is infinite, which is not defined. So 0 is not there. So you take any number, 1 by 2, you will take 2 here. Take any number. For any number you have values here. And it's 101 because you take any number, it has only one injection. For 2, there is only one injection, that is 1 by 2. For 1, there is only one injection, that is 1. You take any number in the codomain or in the image, you will get only one value in the domain. So this is 101. Correct. Now the question is it onto? Yes. Because you take any number, any real number, 1 by that real number is also a real number. 1 by any real star number, because there is non-zero here, it's always a real star number. If this had been a real number, then that was not possible, because 0 is one case, 1 by 0 is not defined. But it is told that all non-zero real numbers. So you take any non-zero real number, 1 by that number is also non-zero real number. So it is onto also. It is surjective because there is no orphan image here. Correct? So it is 1, 1, 1. Now the question says we are changing the pattern now. Instead of r dash to r, it is n to r star. Now the question says it is 101 and onto or not. Since this is a natural number, it will be a number like this: 1, 2, 3, 4, 5, 6, dot dot dot. 1 by 1 is 1, 1 by 2 is 1 by 2, 1 by 3 is 1 by 3, 1 by 4 you get 1 by 4, 1 by 5, 1 by 6, like this. Correct? This kind of number. 1 by 5, 7, 1 by 4, 1 by 6. So if you see any number in this, you will find only one injection. You take 1, there is only one injection. You take 1 by 2, there is only one injection. So it is 101. Now the question is onto or not. If you see here, this is all real star number. That is all non-zero number. They can be number like 2 by 3, right? 5 by 7. They are also non-zero real numbers. But if you see for 2 by 3, there is no image here. Because for 2 by 3, if you say 1 by 2 by 3, it becomes 3 by 2. 3 by 2 is not natural number. But 3 by 2 was non-zero real number. So in this case, for 3 by 2 also, if you see, if you get 3 by 2 here, you get a mapping here, that is 2 by 3 in the earlier case. But in this case, for 3 by 2, For 3 by 2 or 2 by 3, there is no mapping here because 3 by 2 is not a natural number. So there are some orphan elements. Since they are orphan elements, it is non-surjective. That is, it is not onto. So what you have seen, same function, but if you make a change in domain and codomain, the pattern changes. It was from non-zero real numbers to non-zero real numbers. It was 1 1 onto. It is natural number to non-zero real numbers. It is 101, but it is not onto. Alright. Let's check one more example. So we have to check injectivity and surjectivity of the following function. The first function is fx is equal to x square from n to n. The second is fx is equal to x square from z to z. And the third is the same function fx is equal to x square from r to r. If you see, the function is same, but the domain and codomain is changing. So we'll take the first scenario from n to n. So let's take this value from n to n, right? From n to n. If you take a natural number, it will be something like this: 1, 2, 3, 4, 5, dot dot dot. So if you take 1 square, you get 1, or you'll write like this: 1, 2, 3, 4, 5, 6, 7, 8, all natural numbers. You take 1 square, you get 1. You get 2 square, you get 4. You get 3 square, you get 9. You get 4 square, you get 16. See the natural number. You get 5 square, you get 25. Like 25. But if you see here, for any number, if you take 1, there's only one injection. For 4, there's only one injection, that is 2. For 9, there is only one injection, that is 3. So it is 1 1. Why? Because for any number, there's only one injection. But there are some orphan images here: 2, 3, 5, 6, 7, 8. There's so many orphan images. So it is not onto. Correct? It is 101 but not onto. I'll say 101, or I'll write here only 101 not onto for this scenario. Now I'll take the second scenario. It is from z to z. So if it is from z to z, z is all integers. Z can have values like -1, -2, right? 0, 1, +1, 2, 3, like this. And here also it can have values like this: -1, -2, -3, -4, 0, 1, 2, 3, 4. Those values it can have. -1 square, if you make, you get 1. Let me put 1 here actually, just to make things simpler. -1 you get 1, -2 you get 4, 0 square you get 0, 1 you get 1 square is 1, 2 square is 4, 3 square is 9. This is not written, so I'll put it here. So if you see here also, this is one scenario. For 1, there are 2 input, -1 and +1. For 4 also, if you see, there are 2 input, -2 and +2. So there are 2 injections for 1, there are 2 injections for 4. That is, there are multiple injections for numbers. So it is not 101. So it is many one. Correct? Also, if you see, there are so many orphan elements: -1, -2, because I'm telling this codomain is nothing but square, x square, and it has to be always positive. So -1, -2, -6, these are all orphan elements. So it is not onto. So what you have seen, this the same function made me change the range and domain and codomain. It is now many one and not onto. Here it was 101 and not onto. The third is from R to R. There also you will see it will give the same result. I'll not solve this for you. You can solve it on your own. From R to R, if you see, it will have values like -1, -2, -1 by 2, +1 by 2. And here if you see, it will also have those values: -1, -2, +1 by 2, 1. You see, -1 square becomes +1. So I'll take 1 here. And 2 square becomes 4. So +4 I'll take here. -1 by 2 becomes 1 by 4. 1 by 2, -2, 1 by 2 square. +1 by 2 square also becomes 1 by 4. Here if you have, let's suppose, value called 2, So 2 will get the value. So if you see here, 2 minus 2 gives the same value, same injection for 4, 2 and minus 2. So it is not 101, it is many one. Also, if you see, there are so many off elements, minus, all the minus are offense because it is x square actually, and it has to be positive, but there are so many often elements which are negative, so it is not 1. Correct? So what we have seen, the same function with different domain and codomain, the pattern changes, the property of the function changes. Let's take one more example. We have to prove that the greatest integer function from R to R given by fx is equal to x, greatest integer, is neither 101 nor onto, where x denotes the greatest integer less than or equal to x. So we have to prove that the greatest integer function from R to R, domain is R and codomain is also R, is given by fx is equal to this, is neither 101 nor onto. So what we have to do is, this is two circles, we have from R to R. So real numbers can have values like 1.1, 1.2, right, 1.3, 1.4, all these numbers can have. And if you take the mod, if you take this greatest integer function, it will give 1 only as an output. You see, right, all these give the output will be 1 only. Similarly, you can have values like 2.1, 2.2, all will give the output as 2. Since this is a real number, it will have other values also, 1.1, 1.2, 2.1, such kind of value will be there. So this will be the graph. So if you see here, this function, for 1 there are so many injections, so it is not 101. Correct? For 2 also so many injections, so it is not 101, it's many one actually. It is many one. Also, that is one part. Second part is whether it is onto or not. So if we have, for onto, there should not be any orphan element in this image, but we see that there are so many orphan elements. See, when I'm talking about the greatest integer, this will always be some natural number, but here 1.1, 1.2, 1.3, 2.1, these are all orphan elements. Correct? So these are not onto also. This is not 1. Thus this function is neither 101 nor onto. Very simple. What we have done, from R to R, we just draw this to circle, we got the values here, and we found that for number 1 there are so many injections, for number 2 also so many injections, so it is not 101. And also we found that there are so many orphan elements in this image, so it is not onto also. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.